Okay, we're on 6.2, part 2, trig equations. On this one here is to solve each equation for solutions over the interval of 0 degrees to 360 degrees. Give solution to the nearest tenth as appropriate. So we have 4 cosine squared of theta plus 4 cosine theta equals 0 equals 1. Remember, we have to have these things equaling to 0, so I'm going to move this 1 over. So I have 4 cosine squared of theta plus 4 cosine of theta minus 1. And I'm looking at this, and what we need to do is have, to make it easier, we're going to make this look like algebra. So I'm going to let x equal cosine of theta. So that gives me 4x squared plus 4x minus 1 equals 0. And we need to factor this. So the first and last, -4, and the middle was in the bottom. I need factors of -4 to add up to 4. -4 being negative means that these are going, and this is positive, means that these two are going to have opposite signs, and the larger of the two will have a positive. However, there's only 2 factors of 4, 4 and 1, which will not get me to 4, and 2 and 2, which will not get me to 4. So this is not factorable. So instead, we will go to using the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac, all of that over 2a. And in this case, this would be my a, this would be my b, and once I move the 1 over, it becomes my c. So we get x equals -b, so -4, plus or minus b squared, b is 4, so 16, minus 4 times 4 times -1, all over 2a, which is 4, so 8. Yes, I skipped steps, but hopefully you can follow what I was saying. So this gives us -4 plus or minus the square root of 16 plus 16. 4 times 4 is 16 times -1 gives us -16, but this negative at front will make it positive. All over 8. So we get -4 plus or minus the square root of 32 all over 8. Now we're really not looking for this number. What we're looking for is the angles that this is going to give us. So reduce, okay, if you don't reduce, that's fine, because there is, we can clean up this and then reduce, but you'll be less mistakes. You will make less mistakes if you just leave this alone. Now remember, our x is really cosine of theta. So we come over here, and we have cosine of theta equals -4 plus radical 32 all over 8, or cosine of theta equals -4 minus radical 32 all over 8. Okay, so what I'm going to do, so I have a number, I know what the number is, positive, negative, what quadrants I'm working in. I'm going to actually throw this in the calculator and get a number. The, excuse me, so -4 plus square root of 32 divided by 8 gives us 0.2071, and this one over here and divided by 8 is negative 1.207, which is greater than, okay, the absolute value of this is greater than 1, so not in the domain. Anyways, we can't use this one. We can only use this guy here. And it's positive. And remember that all students take calculus. That means we're in quadrant 1 and we're in quadrant 4. So quadrant 1, quadrant 4. And I will put this straight into the calculator. And when I put it into the calculator and round it up, it will become 78.0 degrees. It says to the nearest tenth, I believe. Yes. And then for this one, you're going to do, since you're quadrant 4, it's going to be 360 minus 78, which is going to give us an angle of 282 degrees. And there's our answer. Yes, you should be labeling which one comes from which quadrant to identify that you've got them all, and go from there. All of these problems, I believe, except for maybe the last one, all of these problems require the quadratic formula to be used. Okay, so next problem. This one here, notice I have sine and cosine going on. So we cannot work this problem the way it is. So we're going to start off by squaring both sides. Okay, so this one here is going to go straight to 4 sine squared of theta. This side, however, we do have to FOIL. It's 1 minus 2 cosine of theta times 1 minus 2 cosine of theta. So we get, when we factor this out, 1 times 1 is 1. 1 times this gives us negative 2 cosine of theta. This times this, this times the 1 gives me another negative 2 cosine of theta. And negative times negative is positive. 2 times 2 is 4 cosine squared of theta. Okay, I still have cosine and sine, but we do have an identity here that I can use. So this is going to be 4 times 1 minus cosine squared of theta, so that we can get rid of the, now we have all cosine. So I have 4 times this, which gives me 4 minus 4 cosine squared of theta equals 1 minus 2 cosine of theta. Let's combine our like terms there. That will give me 4. 2 and 2 are 4. Cosine of theta plus 4 cosine squared of theta. Add 4 cosine squared of theta plus 4 cosine squared of theta. And I'm also going to subtract the 4 here, so subtract 4 here. This becomes 0, and on this side we get negative 3 minus 4 cosine of theta plus 8 cosine squared of theta. From this point on, even all of this was algebra. You could have changed this at any point after you change sign. So I'm at this point going to let x equal cosine of theta. So now I have negative 3 minus 4 plus 4x, plus 8x squared equals 0. Just to make my life easier, I put this in descending terms. So 8x squared minus 4x minus 3 equals 0. Check to see if I can factor. 8 times 3 is 24, so negative 24. Negative 4 goes on the bottom, and I need factors of 24 that will add up to 4. The signs will be different, so really it's a subtraction problem. Worst case scenario, you're going to go through all of them. You can go, well, I have 1 and 24. Nope, that won't work. 2 and 12 will get me to 10. 3 and 8 will get me to 5. And 4 and 6 will get me to 2. And then we start from there. 5 is not a factor, and we go to 6, so we're done. There's all of our factors, and they won't work, so we get to use Pythagorean. So this is going to be my A value, this will be my B value, and this will be my C value. Okay, so x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So x equals negative b, the b is already, so negative b plus or minus the square root of negative 4 squared. I skipped these steps in the last one, so I decided not to do it this time. Minus 4 times a, which is 8, times c, which is negative 3, all over 2a, and my a value on this one is 8. So we get x equals 4 plus or minus 16 plus this negative, and that negative is going to make it plus. 3 times 8 is 24, and 24 times 4 is going to get me 96 all over 16. So we get x equals 4 plus or minus square root of 16 plus 96 is 112 all over 16. Again, you do not have to reduce this. I would actually tell you not to. You just got to separate it with this plus minus. Reminder, x was cosine. Cosine of theta equals 4 plus square root of 112 all over 16, or cosine of theta equals 4 minus the square root of 112 over 16. Since this is 4 plus something that's even larger than 4, the square root of 16 or 112 we know is more than 10. We're going to throw that out there. Well, actually, I was going to say this is going to be more than, I don't think it is. So if I find this cosine value, cosine of theta equals, and I plug that in, I get 0.911. And over here, if I plug this values into the calculator, I'm getting negative 0.411. Basically, the idea is that only reason I'm putting these in there is to make sure that this number is not larger than positive 1, and this number is not smaller than negative 1. Throw these into the calculator. This one here, again, we can do that. All students take calculus. All students take calculus. These two here is going to be quadrant 1 and quadrant 4. And this one over here will be quadrant 2, because it's negative, and quadrant 3. Okay, so if I put this one into the calculator, I'm going to get 24.3 degrees. If I do 360 minus the 24.3 degrees, I am going to get 335.7 degrees. Okay. There's my first two answers. Over here, quadrant 2, so I put this into the calculator, I'm going to get 114 degrees, 114.3 degrees. Now to get to quadrant 3, I need to know my reference angle. You get your reference angle by putting this into the calculator as positive instead of negative. So on that one, okay, so on this one, your reference angle is 65.7. So to get to quadrant 3, it's going to be 180 plus the 65.7. So that will give us 245 degrees, 0.7, forgot my point. 245.7 degrees. And there's the 4 angles that this one will work for. So we have on this side, we have 2 angles that will work, and on this side, we have 2 angles that will work. If you want to verify it, you can go back into the calculator and double check it. Check these values and make sure that they work and they give you the value. Okay, so we double check this. I got to throw this out there. If you double check these, the extraneous solutions that they told you, hey, if you square something, check for extraneous solutions. This one is an extraneous solution. Anyways, it's a solution you got, but it doesn't work. If you put it on the sine side, you get a positive number. You put it on the cosine side, you get a negative number. So this answer doesn't work. And the 245 one, this one doesn't work. This one also is an extraneous solution. Now, if you're going, well, how was I supposed to know? I squared them. So that's giving me more answers than I really needed. Remember, it gives me a plus minus. And if we go back to the original problem, sine, this one is automatically going to become negative because it's 2 times whatever this is going to give us a negative value. Well, and this one gives me a positive. So they had to have opposite signs to begin with to be the same. So it only happened in quadrants 2 and 4. So watch those extraneous solutions. Okay, next one. This one here, again, we have more going on than what's there. Okay, so I have secant squared, but I have an identity that will take care of that secant squared. And that identity is 1 plus tangent squared. Okay, I'm going to go ahead and let x equal tangent. So I have 1 plus x squared equals 2x plus 4. I'm going to subtract 2x and move it to this side. Subtract 4 and move it to this side. So I have negative 2x minus 3 plus x squared equals 0. Put this in descending order, you get x squared minus 2x minus 3 equals 0. Okay, so negative 3, factors of negative 3 that give me negative 2 will be negative 3 and 1. So this is nice and factorable. So the lead term here is 1. So if I divide by a negative 1, divide by negative 1, that's what I call Vincent's rule. The negative 3 over 1 gives me positive 3, so x equals 3. X equals 3. And over here, 1 over negative 1 gives me x equals negative 1. Don't forget, x is really tangent. So tangent of theta equals 3. Tangent of theta equals negative 1. This is going to be the easy one. I'm going to throw that out there. This is going to be the easy one because it's a unit circle angle. Tangent, all students take calculus. We don't want those two because they're positive there. This guy's negative, so we want this guy. Let's see, we're in degrees. Degrees. Okay, so on this one in quadrant 2, this guy is 135 degrees. And in quadrant 4, it's 315 degrees. Now we are going to check for extraneous solutions, but I will pause when I'm doing that one. Okay, and then this one here, this is a calculator one. We have to put this into the calculator. So in quadrant 1 is positive, so we're looking at quadrant 1. Quadrant 1 is going to be 71.6 degrees. And in quadrant 3, you're going to do 180 plus 71.6, which is going to give us 251.6 degrees. So this is our solution set, but we do have to double check, make sure that we don't get an extraneous solution on these. Again, I'm going to pause that for those. Okay, so I double checked all of those answers. So I want to compare this one to the last one, where this one we did the this one we didn't have to square it; it was already squared. Where the last one we had to square it to get to the right, to get the same trig function. Now I do want to point out on the ones with quadrant 1 and quadrant 3, we rounded those values. So I need you to realize, because we rounded those values, that it's going to give you, you're going to have a rounding error. They're going to both come out to be 10 point something, but their point somethings are going to be different. But that's okay because we rounded. Okay. This one here, again, between 0 and 360 degrees. Again, we have tangent and cotangent, but luckily they are reciprocals of each other. So I'm going to just go through and divide all of these by cotangent. Divide by cotangent. Divide by cotangent. Divide by cotangent, and divide by cotangent. So this, and then what I'm going to do is I'm going to take the reciprocal and bring this up. So the reciprocal cotangent is tangent. Tangent times tangent is going to give me tangent squared. 1 over cotangent is tangent plus tangent. 1 over cotangent, again, is tangent, so it equals radical 3 tangent. Oops, theta. Plus, and these guys cancel out, plus radical 3. Okay, so I'm going to bring these guys to the other side. So I have now tangent squared of theta plus tangent of theta. Move this guy over by subtracting. So minus radical 3 tangent. And I'm going to subtract this guy also and bring him over, minus radical 3. All of that equals 0. Now this is going to, I'm going to do the same thing as before. Let x equals tangent. So I have x squared plus x minus radical 3x minus radical 3. A little bit easier to deal with. This one here, because there's 4 terms, I'm going to factor by grouping. And I'm basically going to tear it apart right there in the middle. And it's GCFs. Common factor between these two is x. And I factor out the x. I'm left here with x plus, and x divided by x, 1. This one, both have radical 3's on them, and they're both negative. So negative radical 3. And I have left x Now I took the negative out, so I'm left with plus 1, which is what we want. These two parentheses have to be the same. So my factors are x plus 1 and x minus radical 3. So x is going to equal negative 1, and x is going to equal radical 3. Don't forget, x is tangent. So tangent of theta equals negative 1, and we did that in the last one. Quadrant 2, 135 degrees. Quadrant 4, 315 degrees. And then tangent of theta equals radical 3. We're going to be in quadrant 1 and quadrant 3. And this is where you look at your chart and find that this happens at 60 degrees, and 180 plus 60 is going to give you 240 degrees. And there are 4 angles. And since I did not necessarily square anything, it was already squared. Well, we kind of sort of squared. We would want to double check, make sure we don't have any. But since I'm at 26 minutes on this video, we're not going to do that one. Do just watch for that. Actually, I guess I'll. No. Okay, we're not going to do this one because I didn't assign any of these in the homework. Not in homework, so that in the, that's right, we're running out of time. Okay, I am going to add to this homework that I originally assigned 11 through 39, but I also want to assign 35 and 37 to this homework. Okay, and good luck.